Well, good evening everyone. I am Anshuman Mishra from Team CADVEERS, and today I will present our dual arm humanoid based robot design for Cadastra 2026. Well, I want to thank a lot to IIT Jodhpur for giving us opportunity for such a withstanding handheld and really creative competition through which we were able to know our limit, that what we can go through and what we have came through all of this way during the time limit of the competition, which we have done our best CAD model. So what this competition challenged us, basically it required designing a CAD model of a robotic arm. Well, two independent arm mounted on a fixed base and torso. Here as it is a fixed base and torso, and it has multiple servo actuated joints per arm, two different end effector, one fixed gripper and one adaptive open close mechanism, mechanically feasible and manufacturable design. So our approach focused on three key areas, that is robust structural design, functional joint articulation, and particular gripper mechanism. What you are looking at is the culmination of that engineering process. Well, let me walk through our structural foundation, the base and torso structure. The red frame, the frame you see here, it provides primary load path for both arm system. Well, this is not just a simple rectangular platform. We have incorporated multiple structural consideration. First, the base platform is itself provides mounting point for dual servo motor that actuate the shoulder joint. The platform designs accommodates cable routing and provide adequate mass to prevent tip over during arm extension. Second, the vertical support structure, the columns and bracings maintain high rigidity while keeping weight to a minimum. This is a critical because our servo motors operating at around 50 to 20 kg per centimeter cube torque need to articulate the arm smoothly without excessive wobble. The torso structure integrate seamlessly with both arm system. Notice how the arm attach. Here you can notice how the arm attach, how they are moving, how efficient are they to carry out such pick and place operation. Well, our design demonstrate understanding of real-world constraint, servomotor torque limits, weight distribution, and structural rigidity and assembly feasibility. Well, after that, let me break through the component architecture. We have the solder joint system. Well, it is a very unique way that we have thought that we have came across, and I should tell you that the each arm mount on the servo motor that control the lift, the tilt motion that happens through this mechanical robot arm. It is a pan tilt motion. The mounting process are engineered to be rigid and precise. Misalignment here directly affects the end effector accuracy. We have used standard M2.5 fastening pattern that are widely available and reliable around us. So let us move forward to the arm structure. Here you can see that we have our arm structure. So basically I have came to the single assembly of our single arm that we have used in our model, and after that we are going to uh, to examine that how this system is very efficient. Well, each arm mounts on a servo motor. As we know that here is arm, we have used few actuators too, and here is our servo motor which acts very efficiently during a pick and place operation. And here we have two actuators which efficiently it basically moves the body through up and down movement and also through left and right. Here you can see. So this is how efficiently we have gone through every design. It has a claw gripper. Well, in the design you might seem that it may look small, or it may appear small. Well, it was due to the time constraint that we got, but however we tried our best to incorporate everything. And here you can see that how long and how tall this arm can go. Well, it is very feasible. Well, after that, we will move forward to the next thing, that what we have gone through. Well, these motors have adequate reach, approximately 400 plus millimeter from shoulder to wrist, sufficiently load capacity of 2 to 3 kilogram payload capability, and smooth articulation without binding. Well, at the wrist joint, another servo motor control the gripper action. Here you can see that we have here another servo motor, which in case here again does that gripping mechanism. Well, on your left arm we have designed a fixed gripper. Let me focus on that. Here here we have our fixed gripper, and also it is the best gripper. I think it will grip anything regularly shaped, providing the maximum grip strength. Well, no moving of finger and a higher structural rigidity, that we all know, and also simple reliable operation with single servo control. Well, it is a servo actuated finger movement and a variable grip with accommodation, so it's also sensitive motion control for delicate handling. Well, the cable management, you might not be able to notice here, but we have provided the enough port for the cable management. And after that, what distinguishes our design competitively? First, we have structural optimization. The torso, here you can see the torso and the base. It is the torso, you can see this is the torso part, and here it is our base. So what you can see, that the torso and the base are not solid blocks, they are incorporable intelligent bracing. We have evaluated the load path from extended arm and position structural element to resist bending and torsional movement. This provide rigidity for precision pick and place accuracy, minimal unnecessary mass, efficient material uses. Second, that is our component integration. We have used servo motor, cable routing integrated into structure, quick access assembly design for rapid component replacement, symmetrical architecture for balanced operation. And third, that is real world manufacturing awareness. Well, this model is very efficient to be manufactured in real world, and hence I can say, to conclude at last, that this was how we can do, how we have, this is how we got the time, how we have utilized it, how not only me, my team members of Team CADVEERS have done everything relentlessly through their hectic culture. And I also want to thank IIT Jodhpur for giving at last this opportunity.